Hi folks, this is College Algebra Take Home 8. We're given the population of Sasquatch, P, measured in hundreds, in Canada, T years after 2008, is given by this equation. So this is one of these logistic equations we talked about in class. Number one, we're asked to find and interpret P of 0. So there's two parts to this. We have to find it and then we have to interpret what it means. So how do we find P of 0? P of 0 means, well, I look back at the expression P of t. This means P is a function of t. So when I write P of 0, that means everywhere I see a t, I'm going to substitute 0. So it's 75 over 1 plus 74 e to the minus 3 times 0, which is 75 over 1 plus e to the 0 is 1, and so I get 75 over 75, which is 1. So P of 0 equals 1. Now the question is, what does that mean? Well, plugging in 0 for t, t represents the number of years after 2008. So this means we're 0 years after 2008, so we're in the year 2008. So in 2008, now what's P of 0? I'm plugging in t equals 0 and getting the population of Sasquatch, but that's measured in hundreds. So getting a 1 out really means 100. So in 2008, there are 100 Sasquatch in Canada. Okay, so finding it means giving me the number, going through the algebra, and then interpreting it means telling me what's it mean. Number 2, when will the population reach 5,000? Solve exactly with natural logs, then use your calculator to round your answer to the nearest year. So, we want the population to reach 5,000, so 5,000 is a population number. So I want to remember two things. The population is given to me in hundreds. So 5,000 is going to correspond to the P of t being 50, because 5,000 is 50 hundred. So I'm going to have to set this equal to 50 and solve. And so that's what I do. I have 75 over 1 plus 74 e to the negative 3t is equal to 50. My goal is to figure out what the t is. So the t is in the exponent, but it's also in the denominator. So the first thing I'm going to do is get rid of those denominators and multiply both sides by 1 plus 74 e to the negative 3t. I can go ahead and distribute then. I have 50 times 74. I'm just going to leave it like that for now, and you'll see why. I'll subtract 50 off both sides. I get 25 is equal to 50 times 74 e to the minus 3t. And the reason I didn't bother to multiply this out is because I knew I would be eventually dividing by it, and this is going to keep it easier for me to try to simplify. So I finally get e to the negative 3t equal to what? Well, let's look here. I've got 1 over 2 times 74. That's 148. Okay? So, standard practice. The t's in the exponent. First thing you do is to isolate the exponential. So we'll bring it out of the denominator by multiplying both sides by the denominator and then doing the standard isolation. Now we'll apply the natural log to both sides. The natural log is the inverse of the exponential, and so they undo each other. I could write this as negative natural log 148. And then for the grand finale, I can divide both sides by the negative 3. And I got t equals natural log of 148 divided by 3. So that's the exact answer. If you use a calculator, This was roughly, I believe, 1.6, etc. And so this means 1.6 years after 2008. So when will the population reach 5,000? So what's our final answer here? It's somewhere between 2009 and 2010. So we started with 100 of the beasts, and in less than 2 years, their population's already up to 5,000. The very last question is, what's the limiting population of Sasquatch in Canada? And so this is something we talked about with logistic functions. Let's look at the formula. We have P of t is 75 over 1 plus 74 e to the minus 3t. So limiting population, we're talking about t going to infinity. So we're looking at long term. Plugging in t equals 100 years. So in 100 years, 1,000 years, 1,000,000 years, etc. Assuming we still have this model, what's going to happen? When you let t be a very big positive number, this exponent is going to become a very big number, big in absolute value, but it's going to be negative. And if I take e to a very, very large negative power, it itself is going to get closer and closer to 0. So this term then is going to go to 0, which means that this whole thing is going to go to 75 over 1, which is 75. All right, so as we talked about in class, if the logistic function is written in this special form, this numerator is always going to be the horizontal asymptote. That's the corresponds to limiting population. But once again, we have to remember here that P of t is measured in hundreds, and so 75 really corresponds to 7,500. So our final answer, what's the limiting population of Sasquatch? It's 7,500. And that'll do it for Take Home 8.